in this experiment we're going to have a look at the principle of moments, and we're going to do some calculations to calculate the anti-clockwise and clockwise moments on this meter ruler. Right, quite a simple setup here. We've got a meter ruler suspended we've got the retort stand here, Newton meter, piece of string. So we've got the Newton meter, the force meter is pulling up here. Now we can measure the exact value of the force here on the Newton meter, which will come in handy. And we've got slotted masses hanging here. So the slotted masses are going to be pulling down the ruler from this position. Okay, all fixed with G-clamps here so the thing doesn't topple over. Now the pivot. We've got the pivot here, which is, I hope you can see there, we've got a hole in the end of the ruler, a nail going into a cork and held firmly in a clamp stand. Okay. Now, with this being the pivot, the ruler can rotate like this. So like I said, the force meter is pulling the ruler up, so that's providing an anti-clockwise moment on the ruler, and the slotted masses are pulling the ruler down, so they're producing a clockwise moment on the ruler. Okay, so at the moment when the ruler is in equilibrium, obviously the sum of anti-clockwise and clockwise moments should be 0. Okay, they should be equal in each direction. So let's take some measurements. Okay, we've got the meter ruler is pivoted at one end, so I've deliberately pivoted it at the end, so that's at 0. Now I'm going to keep the position of the Newton meter constant, right? So that's actually at, so we've got 360, that's at 365, let's put on there. So that's 370 millimeters. Okay, so the position of the force from the Newton meter is 370 millimeters from the end. Right, Newton, the slotted masses. Now I'm going to vary the slotted masses, and I'm going to vary the position of the slotted masses. I'm going to vary both of these things, but I'm going to keep this position constant. Right, so let's start with 100 grams. 100 grams, obviously being 0.100 kilograms. So we obviously need to convert that into a force in newtons using W equals mg. So let's do some measurements with the 100 grams first. Right. So let's have a position of, so let's start 490. Okay, so the slotted masses is at 490. Okay, so like I said, this position is going to be, we're going to keep that fixed. So slotted masses at, okay, 490. We have a force of 2.6 newtons. Okay, so the Newton meter is reading 2.6. The position of the 100 grams is 490. Okay, let's take that up to, let's go up to 680. Okay, up to 680. The new reading, the new force on the Newton meter is 3.1 newtons. Okay, so 3.1 newtons. Right, let's go up to 790. Okay. New position 790. New force on the Newton meter 3.4 newtons. Okay, let's go up to 880. Just about in shot. Okay, going up to 880. If I zoom that in for you. So now 880. New position. So 880 millimeters from the pivot. New force on the Newton meter, 3 point, okay, I'm going to go with 3.6 newtons. Okay. Right, let's change the value of the mass. Let's change the value of the mass. And now I'm going to go with 200 grams or 0.200 kilograms. Right, let's have a position of slotted masses. I'm going to put the slotted masses at 500 millimeters. 500 millimeters. So I'll just check. Yep, that's still at 370. That's still at 370. Right. The number here, you might be thinking, what the number here? This is the line. This is the line for 370. This is the line for 380. Okay, not this one. Right. New position. New value of slotted masses. 200 grams, 500 millimeters. Force on the Newton meter, 3.9 newtons. 3.9 newtons. Okay. Let's go up to 690. There you go. 690 millimeters. New reading, 4.9 newtons. 4.9 newtons there. Okay, 810. 810. New force on the Newton meter, 5.5 newtons. Okay. Right, let's try one more slotted mass. So now I'm going to go with 300 newtons or 0.300 kilograms. Right, let's go at, trying to pick distances I've not picked before. So 530, so that's 530 millimeters from the pivot. We have a force of 5.5 newtons. 5.5 newtons. Okay. Let's go 680 this time. 680. Okay. Distance of 680 for the slotted masses. We've got a new force. New force on the Newton meter. 6.7 newtons. 6.7 newtons. Finally, last one. Let's go big. Let's go large. Okay. 860. Is that still in shot? Is the big, just about. 860 is the distance from the pivot. Position of the force meter is still the same. Now the reading, the new force on the force meter, let's try to eliminate parallax error. I'm going to go with 8.1 newtons. 8.1 newtons. Right, there we have it. A range of values of mass of slotted masses, distance of slotted masses from the pivot, and force pulling up from the Newton meter. Right, work out your anti-clockwise and clockwise moments in each case and see what we find. Thank you.